So now, the problem number 3 from the from the result of the sieve size analysis. So we are tasked to determine the percent finer than each sieve size and plot a grain size distribution curve. Next is to determine the D at 10, D at 30, and D at 60 from the grain size distribution curve. And next is to calculate the uniformity coefficient and calculate the coefficient of gradation. So next, so this table is to represent the result of the sieve analysis. So this US sieve size number has a corresponding particle diameter. So at US sieve size number 4, it is 4.75. At 10 is 2, 20 is 0.85, 40 is 0.43, 60 is 0.25, 100 is 0.15, and 200 is 0.075. So the mass retained is given by the is given as in the US sieve size it has 0, and at 10 is 18.5, at 20 is 53.2, 40 is 40.5, 60 is 81.8, at 100 is 92.2, 200 is 58.5, and tapan is equal to 26.5. So to get the total mass of the soil, we will sum up the mass retained in every sieve number. So 18.5 plus 53.2 plus 40.5 plus 81.8 plus 92.2 plus 58.5 plus 26.5 is equal to 371.2. So to get the percentage of the mass retained is to divide the mass retained in every sieve number, and then as every sieve size, then divided by the total mass of the soil. So at sieve size number 4, mass retained is 0, therefore the percentage is 0. So at 10 it is equal to 18.5. So the 18.5 divided by 18.5 divided by the total total mass of the soil, it is equal to 4.39. At sieve size number 20, it has a 12.63 percentage of mass retained, and then in 40 it is equal to 21.49. At 60 is 19.4, 100 is 21.89, 200 is 13.889. At in the pan, it has a 6.293 percentage of mass retained. So now, to get the percent finer, we need to minus the 100% by the percentage of the mass retained. So first we will start at 100%. So 100% minus 4.39, well, it is equal to 95.61. Next is 95.61 minus 12.63, it is equal to 82.98. And then 82.98 will minus 21.49, it is equal to 61.49. Next is 61.49 minus 19.4, it is equal to 42.07. Next is 42.07 minus 21.89, it is equal to 20.18, and next is 20.18 is 13.889 is equal to 6.29, and 6.29 minus 6.29 is equal to 0. So now let's go to let's talk about the graph of the particle size distribution curve. So this is the graph. This graph is in graphing this particle size distribution curve, I use Excel to form the particle distribution curve using the values that I have from my table, from the US sieve size, from the particle diameter and the percent finer of the table. So this is the graph that I have made from using the Excel from the Microsoft Word. So as we by inputting the percent finer and the particle diameter, the graph will be the curve is formed, and then to find the D60, D30 and D10, is to interpolate I use the formula in the Excel trend using the percent finer and the particle diameter that consists. So when in 60%, we need to get the percent finer at 82.98 and 61.49, and its corresponding particle diameter to get the particle diameter at D60. So using that trend formula in the Excel, I get the value of D60 at 0. Sorry, the it is supposedly D60 is equal to 0.416, and D10 is equal to 0.1, and D30 is equal to 0.195. So it means that D60 is equal to 0.416 millimeter, and D30 is equal to 195 millimeter, and D10 is equal to 0.1 millimeter. So to find the coefficient of uniformity, using the formula of the coefficient of uniformity is equal to D60 over D10, so it is equal to 4. D60 is equal to 0.416 divided by 0.1, so it is equal to, the coefficient of uniformity is 4.16. So coefficient of the curvature is equal to D30 squared over D10 times D60. So it substitute the given value to the formula, we will have the equation 0.195 squared divided by 0.1 times 0.416. So the coefficient of curvature or coefficient of gradation is equal to 0.914. That's all.